Alright, so these final few problems. Directions are saying solve the quadratic equation using any method you want. But if you do graph, I would like you to plot 5 points and include the solutions. I will say this, in many cases, and these problems that we're going to do, graphing is probably the worst case scenario that you're going to need to do. I just wanted to give you that as an option in case you did not catch the other methods that we can do these, and in fact the other methods that we could do these are way more efficient. Okay, so for example, looking at this one right here, I'm going to go through and I'm going to show you a couple of different ways we could do this problem. Okay, so first way, this one right here, the most, and I mean the most efficient way of solving this problem is understanding that the only variable that you have here, x, is being squared. There's no x terms here. There's no linear terms. In that case, you can just treat this as just any old algebra problem where you're just trying to isolate x, doing reverse order of operations. So what happened to x? First we squared it, then we multiplied by 3. So to undo it, we divide both sides by 3. And that leaves us with x squared being equal to a 5. And then to undo that squaring of that unknown is we take the square root. Okay? And so at this point, all I want from you here at this point, it'd be x would be equal to a positive and a negative. It's both of those cases. And the exact answer possible would be a square root of 5. If you wanted to give me the decimal, I'd accept the decimal. As long as you give it to me to 2 decimal places, that ought to be good enough. But make sure you keep that plus minus. The biggest reason why students have to do this over again on a retake or why they get it wrong, that right there, okay, is that plus minus sign. We cannot miss that plus minus sign when you do this work. Okay, so as you can see, look how very little I wrote here. Very, very, very little. You need to be able to recognize that and do it. Okay, other methods. The rest of the other methods, hey, thanks Boromir, require you to set that equation equal to 0, which is what I just did right there. So if we set that equation equal to 0, now we could do some other things. For example, I suppose we could factor out a greatest common factor of 3, and that would lead us to x squared minus, what would that make, 5 equals 0. Algebra move here to isolate that parentheses group would require us to divide both sides by 3. No harm, no foul over there. We still get 0. And then we'd have x squared minus 5. But this is very similar to the method that we just did. We could add the 5, and then we'd have x squared being equal to a 5. Time to take the square root again. And then sure enough, here's our answer that we had just a couple of seconds ago of plus minus the square root of 5. Okay? Let's look at another method. Once again, Boromir tells us to set it equal to 0. Now I guess you could use the quadratic formula here. Quadratic formula, being very, very careful here. A would be 3. B would actually be, Boromir, thank you, 0. And then actually C would be negative 15. And then you could set up the quadratic formula from there. Take a look. And there you go, taking a look at the quadratic formula, you can see definitely not as efficient, but doable. Just got to realize there that the b had to be 0. And so when you make your b a 0, look at what kind of ends up happening here. When you get here and you do your b squared minus your 4ac, you end up with a positive 180. Now what we have not talked a whole heck of a lot about, if at all, is how you simplify a radical right there. That 180 can be factored into 36 times 5. 36 is a perfect square, and you can take a square root of that perfect square, and the square root of 36 would be 6. And then realize, hey, if we have 0 plus minus 6 square roots of 5, it's really kind of like that 0 really isn't even there at all. So really what we're looking at right there is a plus minus 6 square roots of 5 divided by a 6, and then boom, goodbye 6's, hello 1, times the square root of 5, and that's where that answer is right there. Okay, so that's another way you can do this problem. Hey, do you want one more way? Of course you do. You're screaming for it, aren't you? Here it comes. So once again, this other way, now we're actually going to look at the graph. So once again, set it equal to 0. Type it into the graphing calculator. 3x squared minus 15. Okay, let's take a look at that graph. So there, we have our solutions right there. So in this case, you could give me the decimal approximations for it. So remember how we ended up doing that. You can press the second button. First of all, here's one thing I want you to notice about this graph is that if we go to the table, interesting thing to note, if I go to 0, look at the symmetry going on right there with those y values. Now, why am I pointing out the symmetry? This point I'm bringing up with the symmetry is that if we can get, say, I don't know, the positive guy, the positive 0 here, we can assume that the other 0 must simply be the opposite because of the symmetric nature of that parabola, is axis of symmetry actually being the x-axis. So, how do we do that? Press the second button, press the trace button, and then we're picking 2 to find the 0. Left bound, see where it's at right now, 0, -15. I'm actually sitting on the y-intercept. That's good. That's on the left side of that positive 0 there. So go ahead and press enter. Give us an arrow. Now it wants right bound, so arrow over to the right until we're floating above it. There we go. Press enter. Press enter one more time. Hey, you're looking at about 2.24. You know what that is? That's about what the square root of 5 is, right? 2.23. Watch this. Go here, hit the square root of 5. It's the exact same decimal, about 2.24. Okay, so remember what I was saying about the symmetry of the parabola? If that's about 2.24, that one over there is about -2.24. Now, do you remember how I was talking about getting the table values and plotting at least 5 table values here? This is what I'm talking about. I'd like you to take this graph, if you wanted to solve it by graphing, take this table of values right here and put that on your graph. Okay, Boromir, you can go away. Okay, so now let's plot those points. And so when I'm saying plotting the points here, if you graph, plot 5 points and include the solutions. And what were those solutions again? It was about 2 point, I forgot already. What was it again? It was, oops, wrong way. It was, second quit right there, about 2.24. Yeah, 2.25 if you really want to look at it from that point of view here. So we have zeros right here at about 2.25. And then another one over here at -2.25. See? 2 down, 3 more to go. Makes sense to me to plot that vertex right there at 0, -15. And then we just need 2 more points. How about we just plot these 2 guys right here? See the point I'm talking about? When you plot those 5 points, at least 5 points, you got to include those solutions here this time. Okay, and so now we have 2 other points at 1, -12, and that -112. We can sketch that parabola in carefully. Ooh, got it. Trying to make it bend back around like I did right there. That's kind of bad. I won't try and redo it. Do the best you can with it. Okay? But then also, do you see this right here? Don't forget to write the value of the solution. I'll get students that'll do this. They want to solve by graphing, but guess what? You haven't even told me what x is right here. So x, you got these 2 solutions here. If you just said this, plus or minus, about 2.24, I'd accept it. Okay? And you solved it by graphing. Okay? Awesome.